To draw such graphs, you have to make use of transformations. We learned last time that y equals to 2 to the x has the following graph, right? And I asked you to remember two very important things about this graph, which is that it has a horizontal asymptote at where? Right here. Yeah. What is that horizontal line? Y equals to 0. Okay. At y equal to 0, the graph has an asymptote because if you go extend further to the left, the graph becomes indistinguishable from this horizontal line. That's what I said, right? So that was one thing to remember. The second thing to remember about this graph is that if you plug in 0, you get what? 1, right? So 0, comma 1 is the y-intercept of this graph. And I said, when you try to think about the transformations of this graph, you have to pay attention to this point to see where this one moves to, okay? So these are the two things that you have to pay attention to. Okay, but then before we start moving this thing, there's a minus in front. So let's think about what that is. Y equals to negative 2 to the x, okay? What does that minus do to this graph? It flips over where? X-axis, right? So the graph, see, if you plug in 0 here, what's the value? You get negative of 2 to the 0th power. 2 to the 0th power is 1, so it's negative 1. So you see that the graph should pass through 0, comma negative 1. And if you plug in other values, you don't have to make a table. You can just do mental math. Just think about plugging in 1. What do you get if you plug in 1? Negative 2 to the first part. What's that? Negative 2, right? So at 1, you get negative 2, and you kind of get the point, right? So the values become like this. All the values are negative because of this minus. Is that okay? Yeah. It's 2 to the x, and then there's a minus in front. So all the values are negative. Okay. Now, let's think about what this y equals to negative 2 to the x minus 2 plus 1 does. Okay, so first of all, x minus 2, what does that do? Moves 2 to the right. Okay, 1, what does that do? Moves up by 1. Okay, so what you do is you take this point, you move 1, 2 steps right, and then you move up by 1. Okay, where are you at? 2, comma 0. So you have 2, comma 0 as this, let me put it over here. 2, comma 0 is this new point where this graph should be passing through. Okay? So what you want to do is you want to take this entire graph and move it over here. But there's another one. You know, there was this horizontal asymptote that this graph gets closer and closer to, right? That was y equal to 0. Now, if you take the horizontal line, move it 2 steps right, what do you get? The same thing, because horizontal line, if you move left or right, it's still the same line, right? But then what happens with plus 1? Goes up by 1. So you have the new horizontal asymptote, which is at 1. Y equals to 1 is your new horizontal asymptote. Okay? So now let's draw everything together. The correct answer would now then be, it's a graph that passes through this point with this as your horizontal asymptote. So that's your graph. Okay. All right, now we're almost done, except that it's asking us to find the asymptotes and intercepts. We already found that the asymptote is y equal to 1. That part is okay, but we still need to find the intercepts. So let's find the x and y intercepts. First, let's do the y intercept. How do you get the y-intercept? Set x equal to 0, okay? You set x equal to 0. You take this equation here. You set x as 0. And that's going to be negative 2 to the negative 2 plus 1. And I see some confusion here. I think some people are confused between negative 2 to the negative 2 and negative 2 parenthesis negative 2, because they have different meanings. This one here means that you have minus and then minus of 2 to the negative 2. These are different things. Okay? If you don't have a parenthesis, if you don't see any parenthesis, this means this. Okay, it's not this one. This is different. In fact, in an exponential function, you never have negative to some power as your exponential function. So you never are presented with such a function to draw. That's because if x is a decimal number, say like 1/2, what's that? 1/2 is square root of negative 2. Does that number exist? That's not a real number. Square root of a negative number is not a real number, so you can't draw the graph of it. Okay? So that's why we never consider, so when we consider y equals to a to x, this a has to be positive if we are to draw the graph of it. Okay? Yeah. All right. So it must mean this one, not this one, but let me proceed to give you the explanation how these are different. Okay, so first of all, this one, minus exponent, what does that do? Yeah, it turns into a fraction. It becomes 1 over that thing. Right? It takes the reciprocal and you take the exponent of it, right? And because of that, this is negative 1 over 4. On the other hand, this one, when negative 2 is applied to the entire thing, that's going to be 1 over negative 2 to the second power, which will be 1 over positive 4. So this one is positive 1/4. This is negative 1/4. They're different. Okay, you have to know the difference. So hopefully that's okay. So this is going to be the first case, which is negative 1/4 plus 1. What is negative 1/4 plus 1? 3/4, right? If you have $1 and somebody takes away 1/4 from it, you get 3/4 left, right? Good. All right. So you get 3/4 or 3 over 4 as your y-intercept. How about x-intercept? How do you find x-intercept? Set y as 0. So you have 0 equals to negative 2 to the x minus 2 plus 1. This is what you want to solve. Move this to the other side. And that gives you 2 to the x minus 2 equals to 1. And then you're going to rewrite 1 as 2 to some power. 2 to what power is 1? 2 to the 0th power. So you rewrite this one as 2 to the 0th power. And now you say x minus 2 has to equal to 0 because, see, 2 and 2 matches. So for the entire numbers to be the same, they should have the exact same exponent, right? So their exponents, x minus 2 and 0 has to match. Therefore, x is 2. Okay. Oh, but we already know that. So this work, although we did it, we didn't really need to do it because we already know from the graph that the graph passes through the x-axis at 2, 0. We found that out by moving this point. Somehow usually the graphing process wouldn't reveal the x-intercept exactly, but here we just got lucky. We already knew that. Okay, but we also know now that this point here is 3 over 4. Okay, and that's it. The answer to this question now is this graph with the x-intercept at 2, y-intercept at 3/4, and the horizontal asymptote being y equals to 1. Right? Okay, so try drawing the other one. All right. So for this one, we start with y equals 2 to the x, which is like this. Then you think about y equals to 2 to the negative x. What is this graph when you have a minus in front of x? What? Reflection over the y-axis. Y-axis, right? Because I talked about this picture, right? When x is replaced by negative x, it's a reflection over the y-axis. So it's like taking this picture, flipping this way. If you flip it that way, you end up with this picture, right? This is still 1. This is still y equal to 0 is the horizontal asymptote, same as before. Those didn't change. But now, if you put a minus in front of 2 to the negative x, what happens to the graph? It goes upside down, flips upside down, right? So you take that flip upside down, and this is what you get. Okay? Now, the only thing left to do is plus 4. What does that do? Makes it go up by 4. Okay, so before we do that, let's agree on this coordinate. What's this coordinate for this graph? 0, comma, what? Negative 1. Yeah, if you plug in 0, that's 2 to the 0th power, which is 1. Anything to the 0th power is 1, and you put a minus. Okay, so negative 1. And then if I take this entire thing, move it up, the new horizontal asymptote is, this thing went up by 4, so it's y equals to 4. The new y-intercept is 3, because negative 1 plus 4 is positive 3, right? So this graph is going to go move up, passing through this point, still having this as the asymptote. The graph should look like this. Okay, so with the plus 4, this is what we get, and the only thing left us to do is there's this x-intercept that we have to figure out. Okay, we already know the horizontal asymptote as y equals to 4. We know the y-intercept as 3. The only thing that we don't know is the x-intercept somewhere here, okay? How do you get the x-intercept? Set y as 0. So 0 is equal to negative 2 to the negative x plus 4. Add positive 2 to the negative x both sides. So that's same as moving this over here, right? So it's 2 to the negative x equals to positive 4. And then you rewrite 4 as what? Write it as 2 squared and say, okay, so for these two to be equal, the exponents must be equal to each other. Since the bases are the same, the exponents must equal to each other. And then multiplying by negative 1, we see that x is equal to negative 2. So therefore, here is negative 2, and that's the answer. X-intercept negative 2, y-intercept 3, y equals to 4 is the horizontal asymptote. Good? All right. Let me talk about this number E. E is called the Euler number, and its approximate value is 2.718. And the reason this number is so important is that it has this property that if you draw this number as x, see, this is just a bit bigger than 2 and less than 3, right? So the graph is not that different from 2 to the x. Right? It's just slightly more steeper than 2 to the x. So maybe I might say it's more like that, steeper. Okay. And it has this property that if you draw a tangent line at 0, this is exactly 45 degrees from the x-axis. So this angle right here is 45 degrees. That's the property that this graph enjoys. Now the slope of 45 degrees is 1, and at this level it's impossible to explain why that's so important, but even if you don't understand, let me try to explain why we think of this as something important. So there is the concept of a slope of a function called a derivative. So something like the derivative of x squared is 2x. This is something that you learn in Math 111. So it's like we're never going to talk about this in this class, but it's something that you learn later. Okay. So one of the things that you see is that if you have 2 to the x power, then its derivative is known to be 2 to the x times some mysterious thing. We didn't even learn logs yet, so I can't explain what this number is, but this is just some, yeah, it's something slightly bigger than 0 and less than 1, okay? Some positive value. It's I don't even know the exact value for this one, okay? Oh, it's like 0.69 something something, it's like almost 0.70, okay? That's the approximate value for this. And on the other hand, if you take e to the x prime, this is just e to the x. Okay? And the reason for that is it has something to do with the fact that the slope at 0 is exactly 1. Okay? So that's the reason why this becomes such an important thing. If you later work with any kind of math that's useful, say statistics or some other economics theory or whatever, you're going to see this number e a lot. Okay, and if you wonder later why this is such an important number, it has to do with this fact. It's just somewhat more convenient to use in the context of derivatives. Okay. All right. So this is not irrelevant for this class, but I still had to talk about that irrelevant part to explain why we're doing this e thing. So in this class, the only thing that you have to know is that y equals to e to the x has the graph that's pretty much the same thing as 2 to the x. It's just slightly steeper. That's all it is. Okay. All right. So assuming that this made sense, okay. Let me show you a type of question that could be asked at this level. So sketch negative e to the negative x minus 2. Oh, no, sorry, that's not what I wanted. 1 minus x minus 2. Okay. Let's think about how to draw this picture. Okay, so first of all, you start with y equals to e to the x, which we already have here, but then if I put a minus x, what happens to the graph? What's that graph? Flips over the y-axis, yes. So you're going to get a graph that looks like this. Now, anything to the 0th power is 1, so it's still true that this point is 0, 1, and it's still true that the horizontal asymptote is y equal to 0. Okay, so that didn't change from 2 to the x. Whether you have y equals 2 to the x or 3 to the x or 10 to the x, it's always true that 1 is the y-intercept and y equal to 0 is the horizontal asymptote, all right? Okay, so you're going to flip it around and write it this way. And then what happens if you put a minus in front? it flips over the x-axis and it becomes upside down. So this is the graph. So let's see. This one here is y equals to e to the negative x, and this one here is the graph of y equals to negative e to the negative x. Okay, now the challenge is, now we have to take this and make that 1 and negative 2 appear. So you have y equals to negative e to the 1 minus x minus 2. And the question is, what does this 1 do? What does this minus 2 do? And probably this is easy. Well, what does this minus 2 do? Makes it go down 2, right? So now the only mysterious part of this is, what does this 1 do? Okay, what do you think that 1 is going to do? Go left by 1? Okay. Anyone else? Huh? I think it's left by 1 also. Left by 1 also? Okay. Anybody with a different opinion? Anyone thinking right by 1? Yeah? Yeah. Oh, wait. Yeah, you think right by 1? Okay. Yeah. How many of you say left by 1? I don't know, because the 1 is positive. The x is negative. How many of you think right by 1? Okay. It's either left or right. It can't be up or down, because this minus 2 will be going up or down. If it's minus 2, it goes down by 2. If it's plus 2, it goes up by 2. Okay? So it's either right or left. And the real problem here is you don't know what this plus 1 is doing because of this minus in front. Okay? So in order to figure that out, the easier way to figure it out is to actually start from here and try out 2 different movements. So if you did right by 1, what are you supposed to replace x by? X should be replaced by? To go right by 1, what do you do? X minus 1, right? Okay, if you want to move left by 1, you do y equals to negative e to the negative x plus 1, right? Okay. Now, which one of these are same as this part? This one, right, going right by 1, right? So because if you multiply the minus, this is negative e to the negative x plus 1, which is same as negative e to the 1 minus x, right? So this one is actually going right by 1. And my suggestion is, since trying to figure it out this way is hard, try to reverse engineer. See, how would you make this go right by 1 or left by 1? If you do it, then you see that one of them matches with this one, and it's the right by 1 that works. Okay? Yes? When it's positive, it's still left. No, that's not the rule. The rule is that if you replace x by x minus 1, it moves right by 1. That's the rule. If you know it the other way, that's not the correct one. Okay? Replacement makes the graph go the opposite way. If you replace x by x plus 2, the graph moves negative 2 in the x direction, which is going left by 2. Okay? The important word here is replace. Okay? All right, so this moves right by 1 and goes down 2. So 1 right, down 2. Okay. So let's draw the graph. And the important thing that you should pay attention to is this point. What is this point in the graph of y equals negative e to the negative x? What is this? Negative 1. 0, comma, negative 1. Yeah, 0, comma, negative 1. And that point, 0, comma, negative 1, if you move 1 step right and down 2, where am I? Where is this point? Give me the coordinates. 0? 1, comma, negative 3. Yes. Okay. That's what it is. So you're drawing this graph because we are moving this thing. you're drawing this graph passing through this point, okay? How about the y, how about the horizontal asymptote? -2, because only going up or down changes the horizontal asymptote, and we made it go down by 2, so this is your horizontal asymptote, right? And then you go like this. Yeah. Okay. Now that graph tells me that there's a y-intercept. How do you get the y-intercept? Set x equal to 0. So y-intercept is y equals to negative e to the 1 minus 0 minus 2. And that's just e to the first power. Anything to the first power is itself. So it's negative e minus 2. Yes. So this is 2.718. So negative 2.7 minus 2 will be about negative 4.7182. Okay. So that's the approximate value. But to write down the exact coordinates, that's what you have to do. This you should leave it like this. Okay. Yeah. So that's your y-intercept. This y-intercept is negative e minus 2. That's the final answer.